Welcome to the project demonstration of Scalar and Vector Controlled Infinite Level Inverter Topology Fed Open-Ended 3-Phase Induction Motor. So we are demonstrating that same inverter with the help of the single-phase induction motor, as we are using this single-phase induction motor 230 volts operated 0.14 ampere rating system. So this will be driven by the inverter circuit, which is a 2 n+1 levels. Here we are using the 1 HV circuits along with half HV circuits. These two are used to provide the 12 volts DC to 230 volts AC with 50 hertz of frequency, that to sine wave signal. So that is the input to the AC induction motor. As we know that AC induction motor will drive only with the help of nearby sine wave. It won't run based on the square wave signal, means square wave AC 230 volts. It will run only AC 230 volts sine wave signal that will be generated by these two circuits. One is the full HV circuits and there is a half HV circuits. So here the flow is, we are going to getting the 12 volts DC output from this 12 volt 2 amp battery pack. So this battery pack consists of two sub battery packs. One battery pack consists of 3 4 volt 1 amp batteries are in series, so we'll get 12 volt to 1 amp, and this is 12 volt to 1 amp. These two are in parallel, you will get 12 volts 2 amp DC output. So that is input to the HV circuit initially, and from here a microcontroller will generate the AC signal to provide the AC output from this HV circuits. So that is input to the half HV again to make the constant AC signal of sine wave, means in order to remove the digital signal, as the controller can't provide the analog PWM signals, so it will generate the square wave in terms of sine wave signals. Nothing but we are going to dividing the analog sine signal to digital sine signal. So that signal is generated in this manner. So here this is the main output we need to get, but the microcontroller can't generate the analog signal, so it can convert that analog signal to digital in this manner. Means so these two MOSFETs will getting on and off in this manner, like based on the timing for the sine wave on time. So it's a low on time, and the next we are increasing the on time, and next we are increasing the on time. So once we reach the peak around 90 degrees completed, whenever the positive half cycle 90 degrees completes, then it will keep on decreasing the on time until same for the negative current, and again same once reaches the 270 degrees of signal, and then next current will be done to the negative half cycle with the decrement of timing signal. So this will be achieved by the microcontroller, and we have coded in that manner, and the same signal will be given to the again half H bridge in order to maintain this very smoother manner. That's why we are using the infinity loop fed induction motor. So this infinity loop we are going to convert in that. This is like in real time it's going to be this one is a 7 level inverter. So but now we are implementing that infinity loop by decreasing the on signal time. So we are going to getting the flawless of pure AC signal, and that will be the input to our step up transformer, which will step up the 12 volts AC to 230 volts AC. So here the power flow is 12 volts 2 amp battery pack input to the inverting circuits, and these two inverting circuits will convert that 12 volts DC to 12 volts sine wave AC, and that will be step up to the 230 volts AC with the help of this step up transformer, which is of 12 volts to 230 volts. 3 ampere current can be handled by this type of transformer. So as we are using the rechargeable battery, in order to recharge the battery, we have provided the charging circuits, so which will take 230 volts AC inputs, and step down transformer will step down the 230 volts AC to 12 volts of AC. So this 12 volts AC will be converted into 12 volts DC with the help of this regulated power supply circuit. So that 12 volts DC input to the 12 volts 2 amp battery. And before demonstration of this project, we should keep the battery under full charge by switch on the 230 volts AC input to this at least of 6 hours minimum, 8 hours maximum. Once the time completes, automatically this charging circuit will block the current flow in order to protect the battery from overcharging. So we should keep the battery under charge of 6 hours minimum, 8 hours maximum, and then you can disconnect the power supply to this charging circuits, and the final demonstration will be done by just on the switch, and there we can see the motor start rotation. Right. So as we can see, without any vibrations the motor rotation. As we know that if is there any fluctuations occurred while doing this inversion operation, then the motor will provide the vibrations. I mean, we are providing the smooth AC signal to that, then we are going to get the smooth running of the AC induction motor. If you want to see the signals in the CRO, by just remove the sleeve on these cables. Initially switch off this first, and then you can just remove the sleeves on this one, connect that to the CRO probes, and you can on the power supply. There we can see the AC signal on a CRO output. So coming to the ratings of the MOSFETs, we are using IRF Z44 here, and here we are using IRF 540 and 9540, two types of MOSFETs. IRF 540 is the N channel MOSFET and IRF 9540 is the P channel MOSFETs we are using. And our microcontroller is PIC16F72 microcontroller.